All right, ladies and gents. So, as we progress and talk about stars, okay, I want you to follow along. And as you follow along, take a look here at this table, okay? These have some of our most popular stars. Betelgeuse is a very popular star that is one of our hottest stars in the solar system. Rigel is another extremely hot star to know about. So pay attention to this table as I explain to you the colors of stars, the life cycle of stars, okay? So you should know the basics now that stars have different colors. The different colors actually indicate the temperature of a star, okay? I'm going to move down here. The temperature in a star, the hottest star is blue, okay? And the cooler it gets, the redder it gets, okay? The absolute value of stars is shown here in this table on the left side. Bright stars, whoa, Rigel, they are at the top. Dimmer stars are at the bottom right here, okay? Like Sirius B, these are dimmer stars. Going to talk about the life cycle of a star. Stars begin, we learned this the other day, as a cloud of dust called everybody say it, nebula. Okay? Imagine this enormous cloud of gas and dust many light years across. Well, then gravity begins to pull these materials together. Then the next part of the life cycle is called a protostar. So after nebula, protostar. Eventually, enough gas and dust have been collected into a giant ball with the help of a science process called nuclear fusion. Nuclear fusion. This star becomes a main sequence star in the life cycle. Stars in this state will remain for thousands to billions of years. On average, the temperature is around 11,000 degrees Fahrenheit. After the hydrogen fuel begins to deplete or fade away, it begins to die. The star then expands as it grows old. The next part of the life cycle is it becomes a red giant. Red giant. What happens to the star at the end of this life cycle depends on the size of the star. Remember, it has a choice. It might say, just like our sun, I'm going to stay at a medium mass and then eventually become a red giant. Okay. But eventually, when that remaining fuel, which is hydrogen and helium, it becomes exhausted, the outer layers of the star start to drift off. This creates the next part of the life cycle, a white dwarf. A white dwarf is considered to be a stable star with no nuclear fuel. It then radiates its leftover heat for billions of years. The outer shell is called a planetary nebula. When the heavy gases of the nebula traveled past the gravitational pull, it leaves behind that white dwarf. White dwarfs slowly cool and fade. When it stops shining, it becomes a dead star. A dead star is also called a black dwarf. These stars are burnt out and they don't have any light or heat. These large, massive stars burn up their fuel. Remember, fuel is gas, hydrogen, much faster than smaller stars do. When the fuel begins to run out, the core contracts and the star expands into a red supergiant, the largest stars in existence. Red giant stars only live for a short time, though. They use up their hydrogen much faster. When they get old, they may collapse and explode, and this explosion is called a supernova. After the supernova, it becomes a neutron star. These stars are extremely small and incredibly dense. When that star begins to spin, it might become a pulsar. They emit regular pulses of radio waves and other electromagnetic radiation at rates of up to 1,000 pulses a second. If there's any leftover material from that supernova to become a neutron star, it might actually become a black hole. A black